So it's time to start. It's 10 a.m. So welcome everyone to our webinar number 6, I suppose. Yeah, session number 6. It's more and more people of us. We're now the team of 5, or how many people are we? That's just awesome. And now we will.
Something like that, yeah.
Yeah. So today is a big day for us. We are going to introduce 2 more different projects and 2 people. So one of them is new, and one of them already joined a couple of our webinars before. And I think this time we won't do this long introduction, and we will just give the floor to our new guys. And if you will just quickly introduce yourselves, it will be super awesome. So welcome, Sebastian and Dmitry. Feel free to introduce yourselves.
Hey. Yeah, just a quick one. Sebastian, you might know me from one of the other webinars. I'm working together with Igor. He brought me in the background. I'm a statistician, and now I'm working with Igor and at Graham. Yeah, I'm a solution architect there.
Great. Welcome.
Hi, everyone. I'm Dmitro. I used to work with Alex before. I'm a full-stack engineer, work at KPN in the Netherlands. In my line of work, I mostly, right now, I'm working on React Native and Python on backend.
Nice. Cool. Thanks for the introduction, guys. So today the session will be a bit different than it was before. We used to have only one topic and discussed it during the whole session, but today we have 2 topics. So we will, the first approximately half an hour, we'll talk about the first one. So it will be Sebastian and his amazing GANs. And then we will switch to Dmitry and he will tell us about his mobile app and Flutter. So I suggest we will start with Sebastian and give him the floor.
Yeah. And if you have any questions, feel free to post them in the chat, and hopefully our host will drop it to Basti as well.
Yep. Cool.
Perfect. So can you hear me properly, Igor?
Yeah, I can. And I'm here with you, and I will put you.
Great. Good. All right. Perfect. Yeah. You know what my project is about? It's about called SailMapAI, right? Fancy logo. But you might want to know what it's all about. But first of all, let me ask you, what do you know about Seamaps in general, or navigational charts?
What's your connection to that? Nice that you mentioned navigation, because when you say Seamap, I'm thinking about not the sea, not the MEA, but just some IT term, Seamap. But what do I know about the navigational map? I think I know nothing, because I'm not a sailor. So I used the ferries a couple of times, but I suppose ferries don't use the sea maps, or actually maybe they do. So honestly, I have no idea, but I think that it's a bit hard.
But you might have a rough understanding how a map like this looks.
Yeah,
like,
so
right?
I suppose
so you might. So I would show you a few. I would show you just a few images. What I think like most people anticipate sea maps with. So this is a proper navigational chart here. You can see that one is just printed out, but all the people that have ever like used that or made a course or anything, they will know these charts. They're actually huge. The white areas are basically deep sea, and blue areas are shallow sea, and then yellow and green is land, right? Depending on how the tide is. Yeah. And then there's a lot of information on these charts. So I don't know if you can see this. There is like navigational information, tide, current. So there's a lot on that. And for this, I don't think that it will be that easy to reproduce it. What I was all about is, or when I am on a ship and I make a sailing trip, I normally have something like a harbor guide. Those charts you have on a chart plotter. So you have a plotter on So a screen basically on your boat, and there you have the proper charts where you can zoom in and stuff, and that's all there, and that's nice. But what I use is a harbor guide. So for example, for Croatia, there's a cool harbor guide. It's images like this, right? It looks a little bit hand drawn. Yeah, it's but it's still a bit like here you can see one of these, or here an island.
Actually, it looks a bit like a treasure map.
There's one cool harbor guide I used. It totally. It's also a lot of fun to use these because it's like a comic. It's like animated. You can really like easily find out where is what. It's even easier to read for me as a sailor than any Google Maps or something like this, because the information is just a bit more down on what is there actually in the water, or like and no other things like you can see on a Google Maps chart. So for example, think of the Google Maps. Maybe the printout is not that nice here. There's the same island in Google Maps. Yeah, you cannot really use this for sailing. You wouldn't even really know where it's shallow, where it's deep. So it's not that good for sailing. So I wanted to have something of this for my next trip in Greece. And there are harbor guides, but those harbor guides, you might not use them, like you don't have those overview maps as you have for this other harbor guide, which I used for Croatia. So I wanted to think about, okay, what can I use for that? And then I read at the same time about style transfer in a book called Generative Deep Learning from David Foster. Super cool book. I can just recommend that. Where I came to the idea, okay, you can eventually make a project where you transfer this, right? This might be an idea. So you might know a little bit about image processing since you're a data scientist. Do you have any idea how something like this is possible?
Well, as you correctly said, I have some idea about image processing, but mostly from the perspective of how to make it, I don't know, how to cut it, how to take some areas of the image. But honestly, I never worked with GANs. And the book you mentioned, I also haven't read it. I think with GANs, I only read a couple of articles on Medium. And it looks just awesome and a bit like magic. So I'm really looking forward into what could happen with this Seamaps from Google Maps. So we'll be really impressed.
Yeah, exactly. You mentioned one thing already. It's GANs, right? Generative Adversarial Networks. Super cool, rather new technique. I would say 2018, 2019. When the papers about that came out, and it's let's come to that and what this actually is. So I would maybe go about this. You know about convolutional neural networks, right? A little bit. So how this works, right?
Yeah. So convolutional, yeah, they're using it for computer vision, and they are a bit more lightweight than fully connected ones. Yep. Nice. So yeah.
So you would have one image.
Yeah, just go on.
Go ahead. Okay. So you would have two images, and you try to get from this image to this image, and then you can use some sort of CNN or something like this, which connect these two. I assume that you would know how you can, like, what this is, what I try to draw there, right? It's basically, if you look at this is in an easy form, this is a neural network with some layers that are connected, right? But so that gets smaller and smaller. It's like a decoder, like encoder decoder network. It's a bit ugly eventually. So, but you might know it's like several connected layers. Like, let's say this is a normal network, right? And then you can have something like CNNs, where you have different layers that are, let's say, you can apply filters and stuff like that. So you have different, they have different dimensions or something like this, right? And then they get bigger again. It's a bit hard to explain now, but if you know a little bit about CNNs, then it's clear. It's also a form of neural network. So it should not be too far if you know about regular neural networks. And then this is what I tried to draw down here. And you can even go a bit further with generative adversarial neural networks. And yeah, but let's first say this is a regular encoder decoder network here. So you try to come from this map to this map, and therefore you would probably, if you want to do it directly, right, you need paired images, exactly paired. So you want to have this image here, you want to have this image, and you want to come out with that image, and you just feed it a few thousand of these images, a few thousand of matching images, and then eventually you can come up with a network that would really bring it into that form. However, there you need a lot of examples, and I don't have that many examples, so that's not where I want to go. And then they came out with a method like the generative adversarial neural networks, which makes basically a new image out of that image, right? It's not necessarily, it does not look necessarily very much like this image, right? It looked first rather like this image or so. So it's like a new image. I will just draw it down here. It, yeah, might look something like this, right? Not too nice in the first iteration. And then you would compare. You would have another network that would have just one output here, right? And that output says that's a true image or that's a false image. So it's a fake, or it's true or it's fake, right? So you can imagine how this looks like, right? You have another network here that just like goes down and just goes to one node in the end, right? And then it says so this, what you see here, is either true or it's fake, right? And then you also give it, and this is then conditional GAN, you also give it this image here, right? And it says, okay, how close? It basically checks two things. It checks a loss. How far is it between these two here, right? How far is the difference between these two? And how far is the difference between this one? So, and is this a real image, or like how far is the difference between this and this? And is this a real image, or is this a real image, right? So, and since you can generate here, this is a generator, since you can generate a lot of images here, or more images, you don't need that many images. And this works very well for paired images. And there is a paper, I think it's from 2019 already, Pix to Pix. And they actually use it for exactly that purpose. So I think they use Google Maps. You might think, okay, that looks very similar to, you can also use something like this, right? The Google Maps view, right? So they tried it back then for Pix to Pix. I think they tried it with this one, so with the Google images, and that worked pretty fine with the maps. So they could reproduce that. You can read it up in the paper. It works pretty fine. But now there's one thing which you might think, okay, we have a few images, but I don't want to have them paired, right? It's a lot of effort to make them paired. So I might have images like this, right? Or like just this part here. And we have a lot of images of Google Maps, right? But we just have a few images of these. So let's forget about Google Maps here for now. To the Maps view. Let's say we want to compare it to a non-mapped image. Okay. And there you might end up into a problem. You cannot do this, right? You cannot do the comparison between these two, because obviously it will look different, right? Between so you can check whether it's true or false, right? You can check whether this is true or false, and it is of the same style. But what you can't do is you can't compare it to that one, because this one looks, from the shape, it looks completely different to that one, right? So you can't do that. And what the network eventually does is it always produces the same map. It always produces that one, right? If you do not have this feedback here, conditional feedback, right, on this old image, because you just compare if this is real or not, then you would have always the same image. It might always turn out that it's outputting this image, and this discriminator cannot complain about it, because it's a real image, and it's fine. So that's called mode collapse. That problem. And for non-paired images, they came up with a new version. That's what I want to explain to you today, and you can already think about what the idea is. That's called cycle GAN, right? And that's what I want to explain real quick now, not to go into too much detail, because I think otherwise it's a bit boring.
May I just interrupt you for a moment before we jump into? Yeah, I think it's just a small delay between us.
Sure.
So maybe before jumping into cycle GANs, maybe we just recap a bit about in general in GANs. So as I understood it, the system consists of two neural networks. So the first one, this creates some new picture out of the input picture. At first, it just starts from kind of random stuff. And then there is a second neural network, which tells you, is this something that you generated close to the one that you want or not close, right? And then you continue doing it, and then you generate something more meaningful. And then your second discriminator neural network tells you, well, yeah, it's closer, it's closer, it's closer. And in the end, you will get to the image that is close enough to the real one. So that's how I understand it. Is it
correct
like this?
Correct. So the loss function contains out of two things. In this conditional GANs, right? It contains out of, okay, how close is the image to the original image, right? The conditional image, the baseline image, and the discriminator will ask, okay, will output this is a fake or this is not a fake, right? And if it is a fake, then this is driving our loss function up in the generator network, and that will hopefully increase our generator network, and that will they both play like a game of being better and tricking the other one. That's the idea. But I think you got it right. Yeah.
Cool. Thanks.
Okay. Cycle GAN, you ready?
Yeah.
Okay. Let's go for it. We have unpaired images, and this is why I will use this one in the beginning here. I want to come from this to something which looks of the style of this, right? Even though it's not the same thing. Okay. So I have a bunch of images, and they are not necessarily the same. Some of them might, right? Some of them might be the same, but let's say now we have something like this. And then in the first place, we train again a generator. Looks like this. Generator from let's call this Google Maps to Maps or Seamaps. So from G to S. I don't know if you can properly see that. It's a bit small. It means generator from G to S. Okay. And then it will output us some form of maybe in the first iteration a bit of an ugly map. But we train it the same way we did it, right? And use this discriminator here again, that outputs true or false or true or fake. And we will probably end up into mode collapse. And what we do now, and this is a smart thing, the smartest thing of cycle GAN here, is we train another generator, that from this Seamap, which we generated and which maybe looks good in the end, because this discriminator did a good job and they work properly together. Now you try to map it back to a Google Maps. Okay. So we try to find the Google Maps, and then what we do is we have here a Google Map, and it tries to bring it back to a Google Map. Okay, we have another discriminator here. It does the exact same thing like over there, true or fake, and it should output that again. However, the problem can still occur of mode collapse, and you can still generate every time the same thing because it's unpaired, right? And you cannot have the feedback. Where the feedback comes into the game is here now. You compare this output here to this input in the beginning. Okay, can you see this? And this is what you call identity loss, I guess. This is what they call it. Loss ID, right? And then you have these two loss, and you can call them A1, adversarial 1, and loss adversarial 2. Okay?
Yeah.
And with with this architecture now, where you compare the beginning map and the end map, right? And you check if this is the same. Obviously, if it would, like in the middle, it outputs always this other map here, this like strange map that does not fit, right? It's just the same style. The discriminator says, okay, it's the same style, so it brings it into the same style, but still you would have the problem of mode collapse. Again here, still problem of mode collapse, but it looks like a Google Maps, so it might still be a Google Maps. But therefore, that you say, okay, you have this identity loss as well, it trains it hopefully into the right direction, right? So that you actually also compare if this looks like the old image and it does not reproduce old images from other parts of the sea. And then your loss function in your overall loss function then is something like, and you can properly stack them together. I think what they did is kind of a mean of all the other loss functions, so something like loss ID plus loss A1 plus loss A2 divided by 3 or something like this, right? Then you would have something like they're weighted equally, but you can weight them differently. Yeah.
May I interrupt you again?
This is CycleGAN. Actually, there's sure.
So I think that I'm a bit lost regarding the first discriminator, let's say. So what does it try to discriminate? So you have the original one, then you transform it
this one?
to the, yes, exactly, this one. So how does it work?
So you would hopefully end up with the same style because you compare it to an image that of the same style, right? So it would hopefully look like it looked like the style of this, right? It's some image that has the style of this, okay? And then this one here, from this, whatever the output of this is, then you try to map it back to something that looks like a Google map.
Yep.
Okay. And these are only for the style. So these discriminators are only checking the style. And at some point you want to map it back because you don't want to have mode collapse. So this means that you don't want to generate something that looks like something which was in the training sample. This is why you have this feedback loop. This is my understanding of what the cycle does.
And this style that you say that it checks whether it's the same style, so you have to somehow define the how far the styles are from each other, or there's something default for this.
Good point. We hope that so we don't need to include this in the loss function. We hope that it's actually similar by this discriminator, that it checks because it says, okay, this is close to reality or not. Right, and it's inherent in this discriminator, and that gets better trained over time. So we don't need to have a fancy loss function. I think they even did it with a quadratic loss, and then they got to a not to a quadratic loss, but to a very naive loss function. It does not need to be very fancy. It's basically very easy. You also, by the way, I just for the simplicity, they do it in the same way. Also, like they input something like this here. And they train it similarly. They use this function here. They have, right, the generator from Seamap to map. Use this here. Generator Seamap to map. Then they output something like a Seamap. Then they output like something like a Google Maps, hopefully, right? Have a discriminator here. So the exact same thing, just in the other direction. From G to S. So this is this one. And then they output here a Seamap. Again, right? And then you compare again Seamap to Seamap. Okay?
Yeah.
So then the translation works in both directions. You can also hopefully from a Seamap you have in the end, you can also output something that looks how a Google Maps image would look like. And that's the fun about it, actually, that you have both directions. But for simplicity, I would forget this lower part here. However, does it make sense so far?
Yeah, I mean, it's a bit a lot of information, but it makes sense. Yeah.
I can assume, yeah. I would just just to recap, I would just write down what options we have. And then there is actually one more option, which I think I won't explain in too much detail now, but it's interesting to know about that, because you might know about some apps that you just feed one image of some random style, so some painting or so, some artist, and then it generates from your image, it generates this other style from it, right?
Yeah.
And there you don't have a bunch of images, you just have one image. And that's a cool thing, and that's what I also want to describe. But give me 1 second. We have pix to pix, right? Or conditional GAN. Very ugly, sorry. Right, and there our training data is paired images. Paired images. What does this mean? It needs to be exactly this Google Maps map or image, satellite image, and exactly this output in the map, right? And then you also have this what we discussed, cycle GAN, and therefore you can use unpaired training images. What does this mean? You have something like this and some other map here, right? And then, and that's the neural style transfer. This is the third option, and this is probably, it's very small what you can see here, but this means neural style transfer. And this one is actually fancy because you just need one input image, that's the baseline image, basically, content image, and you need one output image, right? That should be the style of the old one. How can it do that? We trained for a long time, but here you have a pre-trained network already, plus you have a very fancy loss function. They try to do it by the loss function, what you also anticipated at the beginning. How can we get the right style, right, and still remain with enough information of the original map, which we try to build into with these two things here. We try to build into the network, but what they do here, they do it via the loss function. And what you can do here is you can just use one map. And what you can use, for example, and this would more like be a joke or be a app for fun, is you can use something like this, like some old Seamaps, right? You probably don't have hundreds of these, you just have like a few, and you just want to have, you want to say, okay, I want to have my home, right? I just take a Google Maps image of where I live, right? And then I try to make it into an old Seamap and use that. Probably it works better if you live on the seaside somewhere, but you can, for example, of everything, you could do an old map, right, of every location where you were at vacation or something like this. And this could even be like used for an app or so, I can imagine, right? That would be super fun. So, but what I try now, first, what do you think, what works best from all of these? The big question.
The nice question. So I suppose if you already have a nice pre-trained network, like the third option, if you pre-train it on a nice data set, it might work probably the best, but also I'm a bit confused of the results. So it will output something which is similar, but probably it won't make some Seamap sense. I'm not sure. So it will look like a Seamap, but maybe it won't be a Seamap. And I think the second and the first ways, probably with them, you could make it a bit more to the real one. So it will be not just looking as a Seamap, but actually be a Seamap.
Good explanation. Yeah, I would I would agree if I just would guess, but honestly, I cannot know yet. So I would like to try all of these, or at least try once first, and then try to use another one in comparison if this performs better. But you're right, this one basically uses some information we do not know about because it's only by the loss function. And these two here, there are also generative networks, which means they have some randomness in there, and they probably do not. They only produce a nice output, right? A real output that looks real, but that might not be real. So you might not be able to use even these for navigational purposes. Think about these high resolution things, right, where you have a blurry face, and then you use generative adversarial networks to make it super high resolution. But what it outputs is just what looks real and not what is real. Like the information is not there, and you cannot get it from somewhere. You can also, the network just imagines what happens there. And also but I hope that these depth lines here you can eventually find from these charts here. This would be great. And then I think therefore this conditional GAN would be then a good option. But honestly, I have to try it out, and that's what the project is all about.
Yeah, sounds really awesome. Sounds really awesome. So I suppose there is no magic in the world, kind of. So, and the neural network can't guess something which is not there yet, but you'll do your best, and hopefully it will help you sail. But I hope that it won't be your only map when you will go sailing.
That would be dangerous, yeah.
Cool. Yeah.
Yeah. Thank you.
Thanks a lot for your presentation. I will bring back our guys. And
hey guys.
Yeah.
Wow, Basti. Wow, that's amazing. I tried, to do some questions, but yeah, it's nearly impossible to me. It's like when I try to follow, and it works for some time, but then you drop some term, and even if Igor asks about it, then I'm completely lost on the way you explaining it. I wanted to ask when
it
you
might
had
be
this
my
picture
explanation. Sorry for that.
No, that's a loss of my background, I would say. I had some question when you draw this architecture on the board, and there was a part on the top from right generated map to the left generated map. So I wanted to ask about that. What would that mean? So, but I don't think it now it matters actually. Yeah, I just wanted to.
It's the loss. It's the loss. Basically, it's the comparison between these two, and then you can use whatever comparison you want to, how far you are from these other image. You can use some Euclidean distance or something like this, which would give you a measure between these two.
Oh, nice. And this overall picture that you draw, architecture for this kind of task, it's something that you just want to apply for this specific task for maps generator.
So what I was drawing down there was a simple form of how the network structure actually looks like, because in reality you have small layers that I could not draw down here. In reality, also not how the cycles work. So that is that's not easy to draw here. But yeah, this is what I want to apply on this thing, and it's a rather generic way of doing it. And I hope that there are even in the first place to play around with it, there are packages or something I can use.
Yeah, thanks, Basti. It was an amazing talk. I really looking forward to follow your project.
Thank you.
Same here. Cool. So, were there any questions online that you might want to?
No, unfortunately, the chat is too quiet today. However, we have multiple. Yeah. But yeah, shall we go for the next one then?
Yeah, thanks, Basti. Thanks a lot. So also looking forward to your project. Yep.
Okay. Then let's make our hands dirty with the next one, which is a mobile app with Flutter, right? Is that correct, Dima?
Yeah. So today I wanted to present a kickoff for a mobile application that I'm going to start developing with Flutter, and I wanted to just talk about just a little bit about the motivation behind this project. So in my line of work, I've been recently exposed to a lot of React Native development, and as well as within our company, there is also used the strange technology for me called Flutter that I've never seen before. They just have heard about it, but never seen. So I wanted to get my hands dirty on it a little bit and came up with an idea of how I could do that and share a little bit of the process to a broader amount of people, and maybe share a bit of knowledge and how it all goes. So let me share my screen real quick and just show a little sketch of what exactly am I going to develop. So I thought that following online courses and conferences is kind of a hectic task for me, especially because there are too many resources that you can get those conferences from, and to follow them all, it was a very hard task for me. So I decided to write an application that will allow you to subscribe to channels by your interests. For example, your interest in JavaScript or Python or Go or neural networks, and then the application will just suggest which online or offline conferences you could follow, and keep your personal schedule on this, and send you reminders or even invite you to upcoming events. So, as I said, I was interested in Flutter, so I decided to build it in Flutter. I have to mention that I'm new. Yes?
I think, can you share a screen, please? Yeah.
I'm not sharing the screen?
Perfect now. Thanks.
Okay, so it wasn't, you haven't seen anything?
No, not this picture.
Oh, but you can now see it.
Yeah, it's perfect now, yeah.
Yeah, so yeah, that's what I was talking about the last minute. And yeah, so as I said, I decided to build it in Flutter because Flutter itself is a very interesting technology right now, and it's kind of developing really fast. So if you go to Flutter website, they say that Flutter is a tool built with programming language called Dart. It's a UI WebKit for mobile applications, but since the release of Flutter 2, it's not only for mobile, but you could also build websites and even desktop applications with it. For example, in an article where they presented Flutter 2, they said that Canonical is going to use Flutter as their main platform to build desktop applications from now on, which I think is kind of great. I've even heard of some ideas how to bring Flutter to other platforms, like, for example, TVs. And I know that Netflix is now looking into that, but unfortunately, it's not there yet. So the technology itself is kind of booming, and I think in future it could be very popular. So I think right now is a very good time to jump on that train. So Flutter itself has a very nice infrastructure. So it has pub.dev package manager. It's like Node npm for Node, but this is the same for Dart. So you can find a lot of different packages that you like for it, and basically some of them could suit your needs, or they could be reused, of course. Flutter itself, I think from version 1, it had a little bit of issues with performance. It couldn't be compared to the application written in Flutter could not be as performant as a native application that would be written, of course, in Java for Android or in Swift for iOS. But right now, since version 2, they claim that they have at least 60 FPS, and that's I would say almost as native performance as there is. It also supports a lot of cool development features, and the integration with VS Code is amazing, I would say. So I would like to now quickly demonstrate on how the basic application with Flutter could run on your simulator, either iPhone or Android or even since version 2 in web. So let's try to do that. So this is all integrated within VS Code, which is now trying
you have to install plugin on
there are a few extensions that you have to install. So if you go to extensions and just type in Flutter, you'll see that there are snippets library for it and the Flutter support and debugger. Of course, if you are going to use Dart as main language with Flutter, so you have to install the Dart support as well. Okay, so now the simple application that's generated automatically with Flutter generate command line. After you install Flutter, you could use that. Is launched on iOS simulator, and apart from that, it launches the DevTools, which basically gives you your widget tree and a bunch of other cool stuff that you could use during your development, like performance profiler, CPU profiler, memory, even network usage, and all that. So this application deliberately doesn't use any network, so there's nothing here. But for widget tree, it's basically like developer tools in your favorite browser, just for your native app. And that's built in to the Flutter itself, so you don't have to install anything else, which is kind of cool. There's also a very nice support in VS Code already. So for example, if you open Widget Inspector here, which is basically the same as it will open in the browser, and if you hit whatever widget, it will automatically jump in the code to that widget as well, which is kind of neat. So it's really easy to navigate.
So it's kind of the same experience as with Xcode, but in the other language, and also supported with VS Code. So it's
yeah.
Can you compare it with actually Xcode? Do you have such a background, or not much?
No, not really. I wasn't using Xcode ever before, unfortunately. Yeah, but one more cool thing I wanted to show is that it has, of course, hot reload. I don't think that anything in modern world doesn't, but it's still nice to have. So for example, if I change this title here, it will automatically change in the app without even having to reload the app fully. So for example, React Native has to reload all the JavaScript connected to the application, and that takes some time, depending on the size of your application. That could be a bit annoying. So let's stop that for a second here and try another, for example, the Android simulator, and see if it will work. So I have the simulator open here. Let's see if it assembles.
I guess the simulators are part of the Flutter IDE or the Flutter DevTools, or how it is called. You have to install something, right, to have that.
So yeah, so here, yeah, just to, so for simulators, if you are using Mac and Apple platform, so you have already built-in Apple simulator for your iOS and iPads or iOS devices. In order to use Android, you'll have to install Android Studio and deliberately install one of the simulators that's available there. Like this, for example, is a Nexus 5X device.
All right.
So it still works the same. So basically, Flutter allows you to write once, run everywhere, even on web. Let's just stop the session real quick and try it on Chrome. I think it should also work even faster because, and by the way, I've pre-built this app for Android and iOS. When you first run it, it will take some time to compile, but yeah, that's expected, of course.
Is it? Oh yeah, it says it's launching in Chrome. Okay, I see.
Yeah.
It's like Selenium.
Kind of, yes. So there it is. It's the same app, but in browser. I don't know if there's an ability to distinguish the styling of those three platforms, but stay tuned for the next our next streams, and I will answer that question. Then I would like to talk a little bit about the implementation of the application itself. So in order to get online events, I would need some kind of to get data from somewhere. So at first, I decided to just use the meetup.com API that allows you to get just online meetups with description and links. And yeah, you can use this API for free. Just have to register and get a token. So for the backend part, I think I'm going to use Python because that's the language one of the most languages I'm familiar with for backend. And yeah, apart from the Meetup API, I think as an extension, there are a few other data sources that could be used. First, I plan to use to scrape the newsletters. So some popular newsletters, for example, like Python Weekly, they all have a section below in the end of the newsletter that contains the upcoming events. So that could be a nice data source for it. There are also a couple of other websites, of course, Eventbrite, one of those, but I haven't found yet the API for it. And one other thing I thought I could use is Google Forms to just manually add the conferences, but still I don't know how to work with that programmatically, so we'll have to check it out. I think that would be a very nice journey as well. And the last resort is a Telegram bot that could be used by anyone. And yeah, after some moderation, the submitted conference could be added to a whole database. There are a couple of challenges here, of course. So I would have to think of how to remove duplicates. And yeah, I think that would be a very interesting task as well. So yeah.
Yeah, and basic noise reduction, especially when you use Google Forms or Telegram bots, right? Because this is going to be kind of automated, or whoever will be using that. Indeed. Yeah, a small addition. So Google Forms API is actually should be very, very simple. It just drops all the data to Excel sheet, and you can read it from there. So that's good. Mm-hmm. And I thought, yeah, then the question is how you distribute these Google Forms. That's going to be another challenge then.
You mean make it popular?
Yes.
Yeah, that I don't know yet, but this is an educational project, so I think marketing could be one of the points that we could elaborate on in the future.
Yeah, true. Good one.
So in regards to Flutter implementation of the app itself, I've read a couple of articles and came up with that with an idea that Material app is something that is widely used within Flutter, and it's basically a library of widgets that just lets you build your application, just reusing all those tons of available widgets from already. So that's really neat. You don't have to write your component library yourself, as a lot of big companies like to do. There is also a very interesting approach to handling your state, which is called block. Block stands for business logic component. And this is just an approach how the events and state is handled within the Flutter application. So there are multiple approaches to this, but this is kind of the most popular one. And I will elaborate a bit a bit on this in the future streams, because right now I cannot say anything if that's somewhat different to, for example, Redux in React Native or MobX. But from the first look of it, it does exactly the same, basically. Yeah, and one more addition to the project, I would like to use RxDart just to keep things reactive. The Dart itself has already a very nice implementation of streams, but RxDart just wraps it a little bit to a more convenient way of how people used to comprehend Rx libraries in other languages, for example, RxJS or RxGo or whatnot.
Wow, so another adopter of Rx.
yeah, exactly. And I was quite surprised that it's there because, well, as I said, Dart itself has a very nice streams implementation. So it's kind of interesting. That's pretty much it. So for the future development of the app itself, I thought that it would be really nice to probably save the streams from conferences to be available for people who missed them online, for example, or some teaching materials that were exposed during the conferences. But that will still, it's a matter to change or to discuss in the future. So for now, it will be just a simple calendar with an ability to subscribe to certain streams of events, and we'll see how it goes from there.
Awesome. Can I ask you some questions? I tried to type during the presentation.
Yeah, sure.
Yeah, I was very curious. You showed this registry of Dart packages, right?
Yeah.
I have it up still. I'm just wondering how many actually libraries are available in there, just to know a number, plus or minus. How popular is that?
That's a good question. I've never actually thought. So okay, so in the last, we can see here there's 16,606 packages sorted by popularity.
Okay.
So yeah, and what yeah.
Yeah, do you want to guess how many are in NPM, for example, just to compare it?
3 million something?
Almost. Yeah, it's. I think it's 1.5 million, something like that.
Oh, yeah. Okay, so yeah, 100 times more. I understand, but if you know, with JavaScript, if you have NPM, your node modules folder tends to be a couple of gigabytes right now. I think for a single page application. So.
Oh, speaking about gigabytes, I had another one about that. So my experience with Flutter, yeah, so it's not much. It's I just tried it or touched it once. So my first experience was I was installing the SDK, the Flutter SDK, and I think it took me more than an hour to do so. And most of it was downloading some packages, and that it was around some gigabytes, around 2 gigabytes. Is that still the same experience?
No, I don't think so, actually. So I think it's not that big right now. We can try. Yeah, can try to see. Okay, so it's quite big. It's 3.2 gigabytes. Yeah.
Okay, but it's kind of smooth to install and start working on the tool itself, right?
Yeah, I haven't seen any issues with it before. So it was kind of tough when I first taken a look at that, but that was a long time ago. And then yeah, there were no integration with such neat integration with Visual Code. There were no articles about it. So I think there was only one Google group at the time, but yeah, the situation changed dramatically from that time now. So
okay.
Yeah. So the cache is 3 gigabytes for some reason.
Yeah, that's probably the artifacts from a build and from compilation step, something like that.
Yeah, I think so.
So as I understand your introduction, the Flutter introduces brings performance, so it wants to be the experience of a native performant application, right? And on every platform. That's how I understand it, correct?
Yes.
Nice.
Yes.
And yeah, that's awesome goal. I know that previously on web implementation they used Canvas a lot. Is that still the case for the application built on Flutter?
Yes, it is. So for animations and for transformation, CSS transformations, as you've seen them from web, yes, they use Canvas still.
All right.
So so writing a custom widget that will behave with some easing in as out, I think still will be eventually rendered in a canvas. And yeah, there could be some vector logic behind it that you will need to apply in your Flutter code. But I hope that I will touch that in future streams. So yeah, let's see.
Yeah, let's follow to check what's coming next. Yeah, and I had just a small remark about streams because I also was investigating like what could be a benefit of actually using RX, and points that I marked for myself, and I just wanted to challenge it against you basically. Yeah, it's a standard operators, right? So you interact with the streams in a normal way all over your application. Operators, iterators, flows. It also introduces flows to combine these operators. Asynchronous, streams are asynchronous in general. Immutable, that's a reactive way. Basically, that's called reactive X, I think.
Yep.
Yeah, so that's my points that I made. Maybe you have anything to add there, or maybe excluded.
No, I don't think so at the moment. So thanks for your addition.
Yeah, I was also investigating why should I use RxGo because in Pizza Script I use RxGo. Yeah, still not convinced it's a good idea. And one last.
I cannot elaborate on RxGo. So.
Yeah, that's fine. And I just wanted to say that you link to fill the conference. Feel free to drop, and we will use our channels, of course, to distribute it and have a first feedback.
Okay,
thanks
a lot
for presentation. That's very exciting.
Yeah, hope
Igor. Oh, someone Igor. And he's back. Oh, everyone is back now.
I'm summoned. Cool. Yeah. Thanks a lot for the talk, Dmitry. I'm not a developer. I'm not a mobile developer, so I will just ask stupid questions. I never heard about Dart before. So as I understand, that's a programming language, and you can use Flutter only with this language, or could you use some different languages with this framework?
No, it's only at this point only with this language.
Mm-hmm. Cool. Yeah. So, and just from my interest, if I would like to do something not similar, but kind of similar on Python, what would be the way for me to do that?
Well, I don't think that you could do that in Python because Python is not has no opportunity to be transpiled or cannot be used in native apps at some point. So for web, you could use any web framework that there is. For building API for this project, I think I will use Fast API because it's quite straightforward and it's easy to use. So, but that's only for the APIs. Python is there for desktop. I think there is PyQt or something of a sort. So you could there is a library of visual elements for Python, just for desktop apps, but not for web or native.
Yeah, that answers it. Cool. So do we have some more questions or something to discuss? I think in general it's a cool project.
My side,
so
but yeah, super exciting.
Yeah,
I'm
looking forward
always
to
very
those
impressed by yeah, app developers. That's some
that do stuff
mystery
manually and do some stuff manually, not train some neural network for that.
Yeah, old school.
Wow, I think 1 hour, and it's perfect time to wrap it up. What do you think, Igor?
Yeah, I think the same. We managed to do it quite fast this time. So yeah, as I said, I'm really looking forward to the continuation of both projects. Both of them are really super cool, and we'll see how we will organize them. So what will be the sequence in presenting them. And yeah, I suppose we should thank Dimitri and Sebastian for presenting their projects and ideas.
It was a pleasure.
Really fun. Yeah.
It was a pleasure. Thanks for having us here.
Great. Yeah, and we can just say that we will have the next session on what date is it, Alex? 24th, right?
24th, yeah.
Yeah, 24th of April. Yeah, so 10 a.m. Central European time or 11 a.m. Moscow time. We will have something which we are still not sure about. It will be one of our projects, so please stay tuned. We have different channels.
Yeah, follow any channel. We will announce it quickly, I guess. Yeah.
Yeah. And so for the day, thanks everyone who joined us live on YouTube.
Yeah.
And for everyone who will watch it then on YouTube. See ya. Thanks a lot.
Have a great weekend, everyone. Thanks for being here.
Bye-bye.
Bye.
Bye.
Bye.